Good
All
afternoon and
right.
welcome to this webinar, 4 Things to Know to Secure Your Kubernetes Environment. This event brought to you by Security Magazine is sponsored by Fairwinds. I'm your moderator, Maria Henriquez, Associate Editor at Security Magazine. Thank you for joining us. Today's presenters joining us from Fairwinds are Ivan Fetch, Solutions Architect, and Kendall Miller, President. Don't forget to submit your questions, and later in the program, our presenters will address as many as possible. Today's event is being recorded and archived on securitymagazine.com. And now I am excited to turn it over to today's presenters, Ivan and Kendall.
All right. Thanks, Maria. Let's go ahead and dive in. Welcome, folks. This is 4 Things to Know to Secure Your New Kubernetes Environment. If that's not what you're here for, that's what you're going to get today anyways. So glad to have you. And we'll go ahead and dive in. As mentioned, my name's Kendall Miller. I'm president at Fairwinds. And with me today is Ivan. Ivan, you want to say hi and introduce yourself?
Sure. Thanks, everybody, for joining. My name is Ivan Fetch. I'm a solutions architect with Fairwinds, and I've also spent close to a couple years doing SRE work, helping our customers do all sorts of things Kubernetes. So we're excited to get to talk a little bit about Kubernetes security with you all today.
Yeah, well, so let's get started here. So first of all, tell you a little bit about Fairwinds. We are a Kubernetes company. All we do is Kubernetes. We've been in business about 6.5 years, focused on helping folks do Kubernetes right. So there's a number of different things that we have in that space. We have software that helps folks handle policy-driven configuration validation. Everybody wants to do Kubernetes. Most people are afraid they're going to use it wrong. Our software helps you have confidence you're doing it right. We have a whole bunch of open source because we manage lots of infrastructure across lots of different clients. We have seen what are the macro level problems that people run into with Kubernetes. So we write open source projects to address those things. And then finally, we have services. So that's when people come to us and just say, make my infrastructure problem go away. We can build and maintain Kubernetes-based infrastructure for folks. So we've done that for a long time. We have lots of experience with Kubernetes. That's why we're here to talk to you about it today. So when everything from managing Kubernetes to open source tooling to SaaS software, if you're using Kubernetes, we probably have something for you. We've probably interacted with companies like you, and that's why we're here to talk about this today. So up next, we're going to dive into a poll that we have here. So where are you in your Kubernetes journey? If you could spend a minute and respond to this, it gives us some feedback in terms of knowing where you are, helps us focus a little bit on this discussion, as well as we collect this over time and see how people are advancing in their Kubernetes journey over time. So spend a minute and respond to this if you're just learning about containers or somewhere along the way. And I'm seeing results come in. We've got a few no plans to use it. I always like that. Hopefully we'll change your mind today. Give it just a minute more and then I'll close this up. So if you want to respond to this, go in and click a button. And I'll close it out in 10, 9, 8. I'm not going to count all the way down because that sounds painful. All right, and let's pull up those results. So 66% of you just learning about containers in Kubernetes, 8% using it in production, and a whole whopping 25% with no plans to use it. So we'll be talking today about the security bits of this and why you can use it, why it doesn't have to be terrifying. There is a lot here in terms of Kubernetes is different and a new paradigm, and that can be intimidating for folks. So we'll get to how to approach this in a way that's not terrifying. So let's go ahead and dive in. You ready for this, Ivan?
Yes, let's do it.
All right, so to get started, let's talk about some just foundational pieces of Kubernetes. A couple things that are maybe a surprise to folks, maybe not. Kubernetes is not secure by default. Just by installing and running Kubernetes, you are not immediately going to have security nailed down. And anything that I'm wrong about that with, Ivan?
Yeah, I'll say a little more about that. This is kind of a case of it runs, quote unquote, versus it's 100% secure for my particular environment and use case, those being two opposite ends of a spectrum. So if Kubernetes were completely secure out of the box, it would certainly make it a lot more painful for folks to get started and do a proof of concept and play with Kubernetes a bit in a small test environment on their laptop, and so on and so forth. Having said that, the out-of-box experience with Kubernetes is continuing to become more secure thanks to multiple Kubernetes special interest groups, or SIGs as they're called, putting focus and effort on how can we have Kubernetes continue to be usable and a good out-of-box experience for everyone, including additional focus on default security. I'll talk a little bit about some of the layers in question here that need to be a focus when we're talking about securing Kubernetes. You've got the cluster configuration of your Kubernetes cluster itself. You've got the nodes that your different workloads are running on. So those are your compute instances or your virtual machines or your physical servers running Kubernetes. You've got the pod configuration, which essentially is the configuration that relates to the workloads or the containers that you're running on Kubernetes. So that's separate from the cluster configuration. And then last but not least, you have the container image. So that's the file system that represents the container that you'll be running in Kubernetes. And what is that composed of? And are there security vulnerabilities in that? So that's those are some of those layers. And then Kubernetes itself is composed of layers. I won't go into too much more detail there, but Kubernetes consists of multiple components working together on all nodes. You've got your kubelet, which is an agent that makes Kubernetes stuff talk to each other. You've got your container runtime, which could be a Docker shim or could be containerd. And you also have kubeproxy, which facilitates some of that service discovery networking. Then you've got your control plane, which is the management part of Kubernetes that makes global cluster decisions. And that has a bunch of components, including a database that's replicated, your API server, your scheduler to schedule containers, and so on and so forth. So hopefully this serves as a bit of a kind of primer and a bit of a rush through the different components that come into play here. When we say Kubernetes is not secure by default, this is part of the reason why. And things that we're going to be diving into more here. Go ahead.
Yeah, and I mean, I would throw in here a couple things. Like, one, you can go use a platform as a service or a PaaS, and there are PaaSes out there that handle all the security bits for you. Kubernetes is not a PaaS. It's the closest thing we have to sort of a universal PaaS builder, but it's not even really a foundation for a platform as a service. It's sort of like somebody giving you rebar and a bunch of cement and saying good luck, and you have to know how to go build that foundation. So it's not secure by default. You buy a pre-built house, you can buy a pre-built house that comes with a security system and has a foundation you trust. But if somebody's handing you rebar and cement, you got to know what you're doing to get to there. So that's part of what we're addressing here. And then, the other thing that's foundational here is that everything is ephemeral. And you touched a little bit on some of this, I guess, Ivan, but the paradigm that's different about Kubernetes, and maybe you're already there because you're in the cloud, but everything is ephemeral. Everything is made to come and to go and disappear without you necessarily being prepared for it. So you need to be prepared for that. I don't know. Did I get that right, Ivan, before I move on?
Yeah, I would say the key takeaway here is also that container lifespan is shorter than, for example, virtual machines. And when your application scales up, new containers are run using that same image. And then when the demand is no longer required for that app, it's scaled back down and those containers go away. And those containers, similar to the advent of virtualization, are scheduled across any number of your nodes. So it's a lot more fluid of an environment.
It's not a thing that you're patching and updating all the time. It's a thing that, that containers come and go as new ones are brought in. So these are found. Go ahead.
Yeah, good point about the patching, that instead of patching servers or virtual machines, we now have containers, and the artifact becomes the container image. So we're replacing containers with a new image that has updated software instead of patching something in place. Absolutely.
Yeah. Okay. And these are just the foundational bits. We're going to get into a lot more details here, specifically 4 things that you need to know about Kubernetes security. So we go over the foundational pieces because this is a new paradigm, as I mentioned. And everything in cloud world is new and different. Everything in container orchestration world is new and different. It doesn't have to be intimidating. It doesn't have to be overwhelming. It just is different. It's sort of like switching from Windows to Linux. The first time you use Linux, it feels really intimidating because it's a new paradigm. Once you get used to it, and it's not that overwhelming anymore. So let's go ahead and dive into these 4 things.
All right.
Number 1, use an admission controller to enforce security policies. Why do I want to do that, Ivan?
Well, so with Kubernetes, there's a lot of choice about how you can deploy your containers, your workload to run in Kubernetes, and what kind of permission do those containers need. And there's varying degrees of access that you might give a container. You might have a container that runs as root. You might have a container that has more Linux kernel privileges than another container. Depending on that level of access that you give your container, it could have a degree of access on the underlying Kubernetes node that you may need it to have, but also isn't required at all and becomes a security risk. So for example, if you have a container that has privileges and is also running as root on a node, that container might be able to access the network interface card on that node, which now means it can sniff traffic, it can touch and do things to that network interface that goes way beyond what that container should be able to do. So as a solution to that, we have something in Kubernetes that we call an admission controller. Now this is a validating admission controller. There's other types, but this essentially intercepts requests to the Kubernetes API to validate that request. So you might have fields in a request that you make to the Kubernetes API to deploy an application that you want to make sure those fields meet your standards. So some of those things that I previously mentioned, like the security context of your pod, you might want to make sure that you have particular labels set on your deployments in Kubernetes to help you track usage and cost. You might want to make sure that services you create in Kubernetes are internal only, and you can't create load balancers to expose them to the outside world. And there's more examples as we go. We're going to get into some in future slides as well. But you can, of course, enforce this policy, as they say, quote unquote, shifted farther left, right? So it's best to try to enforce this in something like your CI/CD pipelines. But this admission controller here is referring to that last place to make sure that when someone has administrative access to your cluster or something's being deployed through CI/CD, that these kinds of quote unquote danger zones aren't going to get into your cluster and your policy is enforced.
Well, and part of the reason this matters, when we first started getting into the security pieces related to Kubernetes, where we began with was really a dashboard that showed you ways in which things were misconfigured and insecure. And that's really helpful to take a look at the current state of your production environment and see what's broken and needs improved. But honestly, if you wait until things are in production and broken and then you find out about them, it's too late, right? So part of the reason you want to use an admission controller to enforce security policies is what this is saying is with Kubernetes, you don't want to let anything even get in that's broken. So you want to have something set up beforehand to stop misconfigured, insecure workloads from making it into Kubernetes. Did I get that right?
Yep. What better than a camera to show you there's an intruder in your kitchen than to have that intruder never gain access in the first place? Yes.
It's the admission controller is the bouncer at the door. And I like the bouncer analogy, but the admission controller is hopefully not intimidating, hopefully can't be bought off easily, hopefully has, less self-image issues, etc. I'm sure there's bouncers out there who are wonderful and don't have those things. But the point is, it's a thing to keep bad things out and lean on that admission controller rather than waiting till things are broken in production.
And it's there to help enforce your guardrails and your policies. So the goal is to not make something be so limiting as to impact productivity and to keep your users from being able to deploy the things they need to in the cluster, but to be able to set up these boundaries in such a way that you're enforcing the policies that are most important and business driven, required for things to stay secure in your cluster. Go ahead. Sorry, you were saying?
No, it's okay. And we'll show you there's a couple different tools we can suggest for leveraging the admission controller to enforce those security policies, one of which is very selfishly our software, which we'll get to later, but there are other things out there that do this as well. And Kubernetes has an admission controller built in. That's something that's built into the whole process of that. But number two, let's move on and talk about network policy. So there's a lot of things that Kubernetes does to maintain internal network traffic and make some of that easier for you. But just because you're using Kubernetes, because it's solving some of those problems for you, doesn't mean that out of the box it's built securely. So Ivan, tell us a little bit about why we need to enforce network policy. Where are the things that are going to go wrong with that?
Sure thing. So by default in a Kubernetes cluster, pods can communicate with one another. And when I say pod, I basically mean a container. Kubernetes has this slight abstraction called a pod, where you can technically run multiple containers together. But for those that might not be familiar with that definition, let's just say that a pod is a container for ease here. So pods in a Kubernetes cluster can talk to each other by default from a networking perspective. Kubernetes does have this thing called namespaces where you can divide up the pods you're deploying into your cluster, but those are a logical separation. Namespaces don't in and of themselves actually keep things from talking. So there's a thing in Kubernetes, a resource or an object type called a network policy. And that is essentially like firewall rules for pods. So in order to achieve using network policy, there's a couple things that you want to look into as you're building your cluster, depending on if you're making something on premise or using one of the managed Kubernetes offerings in the cloud. But you want a container network interface, a CNI, that supports network policy. There are some that don't, but if you use something like Calico or something like Cilium, you're going to get network policy fulfilled by that container networking interface. And then you can use network policies to limit things like a pod-to-pod communication. So you might want to keep separate applications from talking to one another unless they need to. You can also use network policy to control egress. So things that leave your cluster for other networks where the cluster lives in your cloud VPC or data center or out to the internet as well. So there's also some extensions that you can take advantage of in the network policy world. CNIs that implement network policy extend the standard network policy resource that exists in Kubernetes. And those extensions give you things like being able to set a default policy in your cluster, which is very useful for a default deny stance, and then also gives you some additional logging and visibility into your network policy. So before I stop talking about this, I'll say that this is similar to the advent of virtual machines when VMs came to the data centers, where a network security boundary that often lived at the network interfaces to servers as they were connected to top of rack switches and so on. That security boundary kind of moved into the VMware cluster of sorts. And a very similar thing is happening here with respect to Kubernetes.
Yeah, I mean, to sum that up a little bit, we're saying everything in the cluster can talk to everything else in the cluster unless you're setting policy to keep that from being the case. And part of the reason you want to limit that is if one thing in the cluster is hacked or insecure or somehow becomes nefarious, it suddenly has access to all the other bits. So the policy enforced from the get-go is important. This might seem obvious, but part of the reason it's on the slide here, and it's one of the four, is not everybody is aware of that. Not everybody addresses that. Some people just assume that the problem will be solved for them, and they can be wrong about that. Right, Ivan?
Yeah, definitely.
Okay. Yeah, doing good. Okay, let's move on to number 3. Separate node versus pod cloud access. So you touched on what a pod is. Maybe it's time to go a little bit into detail about the difference between a pod and a node, Ivan, and then talk about what those things look like.
Yes. So a node in Kubernetes is the server or the virtual machine, or physical compute in the cloud, where you're going to have multiple nodes in your cluster. And those are going to be the machines that are actually going to be running your containers. It's somewhat similar to an ESXi host in a VMware vSphere environment, for example. So when you have a node in the cloud, so something like Amazon Web Services, Google Cloud, Microsoft Azure, and it's possible for compute instances in the cloud to have some kind of access to other cloud resources. And that's typically granted through cloud constructs using identity and access management, or IAM, in the cloud. So where this is heading and how this ties together is that if you have nodes in your Kubernetes cluster that have particular IAM access to resources in cloud, then when you run a pod in your Kubernetes cluster, and anyone could deploy potentially a pod in your cluster that it works in your development group and wants to run your applications in Kubernetes, those pods are going to have the same level of IAM cloud access as your nodes happen to have. So, for example, if a node is capable of describing an S3 or a GCS bucket, or describing your compute instances in cloud, then any pods you run in your Kubernetes cluster are also going to have that same capability. So the solution to this particular security item that we're highlighting here is that you want to use service accounts in your cloud IAM to grant access to the components in your cluster that need cloud access. And then by default, everything else doesn't have any cloud access. So what do I mean by, what would you do this for? What would you grant us access via a service account? It might be add-ons in your cluster. If you're running a cluster in AWS, for example, and you're using the cluster autoscaler, and you're managing that to help scale new nodes into your cluster when there's demand for them, that cluster autoscaler needs cloud access to be able to create new EC2 instances and have them join the cluster. So instead of granting that access to your nodes, grant it via a service account. You also might need applications that you run in your Kubernetes cluster to have some cloud access as well. And you want to grant those applications individual cloud access also through an IAM service account. That might be your app needs to talk to, again, some S3 or GCS bucket to get to object stores or some kind of a managed database, etc. So there's a couple pointers I'll close with here for this section. If you're running an AWS, there's something called IRSA, which I forget what that stands for right off the top of my head, but that's for Amazon EKS. Or if you're running a cluster through another means in AWS, there's other software like Kube2IAM that helps you abstract this. Google has something called workload identity, and Azure uses AD service principals assigned to an Active Directory role. So these are all mechanisms that you want to make sure that you look into and implement in your Kubernetes cluster so that you're only granting cloud IAM to the things that need it.
Yeah, well, you're only granting cloud IAM to the things that need it. So the analogy that I'll use here is, this is without separate access controls set up. You're a little bit looking at, let's say, I have 4 children. So there are 6 people in my house most of the time. And, they have friends over sometimes multiple friends. So let's say, suddenly there's 8 people in my house. And because they're in my house, they suddenly have access to my bank accounts. right? Like that's a little bit what's going on. You don't want everybody in the just because they're in your house to have access to your bank accounts. And it's the same thing here. Just because something's running there, you don't want it to have access to all of those things. It is like, explain a little bit about that, Ivan. I think I've made this sound a little bit similar to the last point. Can you talk a little bit about how those two are clearly different?
Well, first of all, it sounds like I maybe need to come over to your house. I didn't realize that whole bank account thing was.
No, well, I worry about Kubernetes security, but my personal financial security is a low priority.
So let's go back and dig in a little bit. So sorry, which pieces of that do you want to highlight as being different?
Well, so even when I'm giving the example of, somebody being in my house has access to my bank accounts, how's that different from anything that's running in the cluster can talk to anything else that's running in the cluster?
So that anything can talk to anything else was our previous point, kind of
right.
about network policy. So the difference here is that anything else can talk to anything else in the cluster. So the previous point we discussed, that's a networking construct inside of Kubernetes. So 2 pods, completely different applications running in the same cluster, can reach one another if they know how to do so, or if there's we haven't talked about Kubernetes services as a concept because it doesn't really relate to these points directly, but you have service discovery that can happen in Kubernetes, and without digging into that too much, there are ways that these applications can easily reach one another, and without using network policy, that's possible. The differentiation now with respect to this slide and cloud access is that left unchecked, you can have pods in your Kubernetes cluster because they can reach out of the Kubernetes cluster from a networking perspective. They're able to talk to that cloud metadata service that is responsible for, among other things, determining or providing access to cloud resources. So the cloud metadata service is this service that basically lets me say, hey, what access do I have in Amazon or Google Cloud or Azure to do things on the cloud level using the cloud APIs? And so somewhat similar to the network policy solution for the previous pods talking to each other point. The technologies that are in play to limit pods being able to have different cloud IAM access are doing that by intercepting essentially those calls to that cloud metadata service. So it's in a way that they are somewhat close in terms of what the solution looks like. It's effectively a proxy, if you will, or a version of firewalling that access to cloud.
Well, I mean, so much of security is about access, and that's why, we'll move on to this next point, which is also about access, which number 4, create a strategy for role-based access control. And the example that always comes to mind for me with this one is at some point we had a customer who just gave everybody the exact same access to all the things in their Kubernetes cluster. And that was all the things in their Kubernetes cluster, which actually worked fine because they had a team that they could mostly trust, and it was a small team, and they got away with it for a time. And then at some point, one of those engineers quit, and they realized that engineer still had access to that cluster, and they had to tear down the entire cluster and rebuild it because they didn't set up role-based access control for it. But I'm sure you have more to say about this, Ivan, than that.
Yeah, and I want to call out, you just said something that some folks might say, oh, that sounds a little grandiose. They had to tear down the whole cluster in some fashion or rework something considerable to take that access away. But actually, certain methods of managing a Kubernetes cluster, when you pass out those core administrative credentials, Kubernetes uses a certificate authority as part of how it authenticates at its core. There's other ways that we can tie authentication into Kubernetes, but when you give away that certificate, being able to rotate that and change that in your cluster is more disruptive than we all wish that it was. And so Kendall's not exaggerating when he
more
says,
disruptive than we all wish it was is exactly, yeah. That's exactly.
Yep. So we don't want to give away those core credentials. Now, managed services, cloud managed Kubernetes is a little bit different than a cluster that you might use other means to create. And so if you have a GKE cluster and someone is leaving your organization, you can just take away their IAM access to that cluster. So some of this discussion somewhat depends on which cloud you're in or if you're on-prem, but suffice to say that it still holds. Don't give away. If you create a cluster and you have a quote unquote admin user, so for example, if you use kubeadm to roll your own Kubernetes cluster on-prem, and then you have these kind of master or administrative credentials, don't just give those to everyone. So let's talk a little bit about RBAC. If that's cool, I'll kind of dig into this a little bit. Does that work?
Yes, definitely dig. Do all the dig.
So what's RBAC in the first place? Role-based access control. It regulates access to objects in your Kubernetes cluster. We recommend that you manage RBAC as code. So doing so is going to help you track the who and the why of those changes. If you imagine, traditional code Git type workflows, as you have something represented as code, which means you've got it committed into a repository. Maybe you have pull requests or merge requests that help get other eyes on those changes and approve those requests in terms of what's happening and why it's happening and so on. So you get that trackability that's definitely valuable. As far as how to help you manage your role-based access control as code, we happen to have an open source tool. It's available via our Git repository. So if you go to github.com/fairwindsops, that's OPS at the end, you can find one of our many open source tools is called RBAC Manager. And that's a Kubernetes operator that basically helps you to manage your RBAC configuration with less code. I won't go into more detail about how it does that, but there's a good write-up on the RBAC Manager page there on our GitHub repo. Although I will mention
one of our earliest open source tools, widely adopted. People are big fans because using RBAC in Kubernetes is harder than it should be, and with a little bit of help, it makes it a lot easier.
Yeah, and one of the cool things that it does is will let you dynamically bind a role to a namespace when that namespace has a label. So you might be creating namespaces for ephemeral deploys or branch-based deploys or temporary code branches that you want to have a test deployment of that code so that somebody can QA test it or something similar. And by creating a namespace and putting a particular label on that namespace, RBAC Manager is watching for that in the background, and it can apply some role bindings to that namespace for you. And then when the namespace goes away, it sees that label and that namespace no longer exists, and it cleans up after those resources. So not only does RBAC Manager help you in general to manage your RBAC, but it helps you do cool things like that dynamically. So
yeah.
In terms of managing your RBAC, there are default roles that come with Kubernetes: admin, cluster admin, edit, which allows you to make changes to most things, but not cluster-wide things, and then view, which is a read-only role. If you can use those and factor those into your RBAC strategy, we recommend you do so. You can also aggregate the permissions of those roles, so you can essentially change them in the cluster. We only recommend doing that if you've got what Kubernetes calls custom resources. So try to keep those default roles unchanged and create your own roles to augment other permissions that you need to grant to particular groups of users in your Kubernetes. And that helps keep the permissions boundaries clear if you've got Kubernetes roles that map to meaningful names for the people that are going to be using your cluster. And then last but not least, in GKE and Google Kubernetes Engine, it's possible to use Cloud IAM to actually grant access into your Kubernetes cluster. So there's roles in Google Cloud itself that kind of somewhat secretly map into Kubernetes roles. However, this access doesn't show up if you're in the Kubernetes cluster and you're looking at RBAC, so it can be a little bit confusing. So to help with clarity of RBAC, we recommend that you grant the bare minimum access to the cluster, which means you can see that the cluster exists in Google Cloud, and then use Kubernetes RBAC itself to actually grant permissions inside the cluster. However, if you're not about that and you want to grant access in Google IAM, we have another tool called RBAC Lookup. And that has a flag that helps you by showing those RBAC cluster permissions that were actually granted via Google IAM. So we do have an option there if you decide you do want to use those Google constructs in cloud. Let me pause there.
No, that's good. I'm sorry, I lost my mute button and I was coughing there. So, well, let's keep going, and we got to keep moving for time's sake here too, so we can get to some questions, and we'll get to those in a second. We did see one question come through. Please keep them coming. We'll save them for the end, but have some questions at the end. So let's talk about how security is now everyone's job. I mean, this is part of the promise of Kubernetes is, it's one more tool in the DevOps tool chain, and I know that word is abused all day long to high heaven, but with good tooling, service ownership, and a true DevOps culture is possible, and part of that means that the developers that are owning their applications need to also own the security of the things that they're deploying into the infrastructure, and so this is everyone's job now. That the developer needs to have tools that enable them to understand what's insecure, what's out of date, what's over permissioned, what's under permissioned, et cetera, and be able to own that all the way through. And I don't know, anything more you want to say about that, Ivan?
I think it's a kind of a buzzword, but it's true. We hear folks saying shift security left. And I alluded to that a bit when you and I were talking about kind of the policy side of things and that admission controller, that ideally you also shift that stuff left into your CI/CD pipelines, into your continuous integration. So I think that's part of this picture as you move security from kind of a central control point somewhat. It doesn't mean it becomes entirely decentralized, right? But I think moving it out of a central control point into, a little bit of dev, a little bit of ops, and Kubernetes can be a significant part of that consistent, maybe even the somewhat new central point of enforcement.
Yeah. And let's keep going. 69%, about 7 out of 10 companies reported that a misconfiguration incident in their Kubernetes environment, or reported having a misconfiguration related incident in their Kubernetes environment. So misconfiguration continues to be the top security issue. So people misconfigure, that leads to security problems. They over-permission, that leads to security problems. They under-provision, that leads to security problems, and on and on and on. But good configuration stops security problems. In the same way that, building a house without any windows is a lot harder to defend than building a house with windows and doors. And it's the same idea. Getting it right out the gate is going to reduce problems. And so to talk a little bit more about that, and we're going to show you a little bit about Fairwinds tooling in this space, and then we'll move into the Q&A. We'll be brief on this part, but we do build a tool called Fairwinds Insights that focuses on Kubernetes security, policy, and governance controls. So this does shift left into the CI/CD pipeline so that you can enforce and set security standards, and the policy can be enforced by the tooling. You can write custom security policy, write custom policy for your security team, is how I should say that. This is a tool for governance if you are using Kubernetes, or if you're looking at using Kubernetes. In fact, it's quite common for people to come to us and say, we're looking at adopting Kubernetes, and like I said, we're afraid we'll do it wrong, and this is a tool that will help you configure it correctly and deploy things into it that you have confidence are not misconfigured. So we're not going to go into a full-on demo of that today, but I'm going to show you a few things in it and talk you through what that looks like. So this is when you log into Fairwinds Insights, you get a dashboard like this that gives you an overview of a cluster with it. You can see across clusters, you can compare clusters. There's lots more things in here as well, but you'll get an overall health score. We're running a whole bunch of checks. You can see on this particular cluster, there's almost 1,000 checks being run. vast majority of which are passing, but there are a few warning items and then danger items. So we actually prioritize what you need to fix inside your cluster. And then importantly, you can click into that list of action items, and it's going to both give you a description of what's wrong in each one of these things, as well as a remediation. So you don't have to have super experienced Kubernetes engineers to know about how to go about improving things and solving the problems that you're finding in the cluster. Not pictured in this, but you can also assign tickets to people. You can, say something's working the way that you intend it to, or you don't intend to fix it. But you can knock off this big long list of things and see the security posture of your Kubernetes clusters improve over time. We also have some bits here, and again, I'm just giving you a little taste of what this tool looks like. You're welcome to come process with us if you want to see a bit more, get an in-depth demo or even a trial setup. But we do have some cost analytics, and we will tell you if something is over-provisioned, which of your workloads are using the vast majority of your spend. We will tell you how to adjust things and how much money that's going to save you over time. In this picture, we have a couple of lightweight workloads. You're going to save 22 cents a month or 43 cents a month, and that's probably not worth changing very much. But for at any kind of scale, you're going to see significant cost savings by getting your workload requests and limits set right. And Ivan, if you have anything to add to this, feel free to butt in, but otherwise I'll keep going.
Oh, yeah, keep going.
So this is a little bit what it looks like in the CI pipeline. You can see just right here in GitHub, we've got an engineer who's trying to run a container as root and add insecure permissions to a container. And this is the way the average engineer is going to interact with this. You get a nice dashboard as a decision maker at your company. If you're a developer, this is how they're going to interact. They're going to go to push code. They're going to have something that's permissioned, provisioned, whatever, wrong. Circle CI passes it because it passed all your normal tests, but Fairwinds Insights is actually failing it. And you can click on a button there, go into the platform, and it'll show you both what's wrong and how to fix it so that the developer can improve upon the things that they're trying to do. If you're going to enable service ownership at your organization, you need a tool that helps you do that. And that's where Fairwinds Insights sits. And then finally, you can write custom policies. So this is we leverage OPA, Open Policy Agent, and we have a number of example policies in there so you can go in and look at what those things look like. If you're in a high compliance environment or something else where you just need to be able to write custom policy, Fairwinds Insights enables that.
Yeah, one cool thing I'll add around the policy bit here is that when you have multiple clusters that you're managing, Fairwinds Insights gives you this nice ability to manage those policies across all those clusters. So you can put them in Fairwinds Insights in a central place, and you can see them in a view like is shown here, and you can still have them applied to all of your Insights connected clusters, and you can still control. Well, I want them to only be enabled in some of them, and you can use those policies in CI as well. So the CI integration that we have for continuous integration, when you're building and about to deploy your app into Kubernetes, these same policies can be applied to the Kubernetes manifests at that stage as well. So you don't have to wait until all of your CI pipeline is completed, and then you're at that final end stage. Something's about ready to get deployed into your cluster, and then it fails. So unless you like getting cups of coffee over and over while you wait for your CI pipeline, in which case, do whatever.
Why aren't you working? Well, we're deploying, right? That's the old XKCD. So Fairwinds Insights exist to bridge the DevSecOps gap, to secure your clusters, help you achieve compliance, reduce costs, give you multi-cluster visibility. There's a lot more here, but we'll move on because I want to get to some Q&A here. So we do have one last poll here. If you can spend a minute, tell us what is the greatest opportunity to improve your Kubernetes environment, and go ahead and answer this. We've got get help with the basics, general best practice assessments, implementing the right security configuration, saving money, or improving my service availability. If you can spend a minute filling that in, that gives us some feeling for where folks are at there. In the poll, and I'm seeing a few responses come in. Go ahead and fill that out. Again, there's going to be something out there that Fairwinds has for you, if that's a service to help you accomplish something, if that's a tool in our open source tool chain that will help you at scale accomplish something better, move to a more mature organization, or if that's our SaaS platform to enable that service ownership and security and posture management. We're going to have something that's useful for you. And I'm going to close this poll out in just a second. And we'll go ahead and hit close. One more vote. No more votes. One more vote. These numbers are so round. With 75% saying getting help with the basics, and 25% saying implementing the right security configuration is the greatest opportunity to improve your Kubernetes environment. So, yeah, well, we appreciate y'all being with us. We're going to get to some Q&A here, but just real quick, you can go check out, we have a white paper, Kubernetes Security Best Practices, the top 5 security mistakes that you are probably making in Kubernetes. So that's fairwinds.com. You can look through there for the Kubernetes Security Best Practices, or go straight to this URL. The slide deck will be available afterwards if you don't want to write this down. I'm going to go ahead and turn it back over to Maria to facilitate the Q&A.
Well, thank you, Ivan and Kendall, for a great presentation. Before we have our presenters address some questions that have been submitted throughout the program, I wanted to remind you that we would love your feedback in our webinar survey to help improve our programs. And now for the first question. What are the cons of using Kubernetes software with iCloud?
Not sure I completely understand the question.
My guess is that they just mean with cloud in general. What's the con of using Kubernetes with cloud?
Well, I think it's some of the cons that we hear folks be concerned about that we'll have discussions are, sometimes folks are wanting to not feel like there's lock-in. My personal opinion about that is that while it's nice to make sure that you have flexibility across your operating environment, often while you're looking in one particular direction, working to make sure that you don't have some kind of lock-in there and you're focused heavily on that area, there's lock-in happening somewhere else that you may or may not be aware of. So perhaps that's part of what you're thinking about when you pose that question. We actually feel like Kubernetes is a nice answer to the potential concern of lock-in with respect to one cloud over another, because it is this unified platform that you could deploy in, AWS, GCP, Azure, Oracle Cloud, on-prem, et cetera. And once you've got that unified platform in place, you can deploy your workloads essentially the same way because you've got that unified Kubernetes API.
Good.
Okay.
Yeah, go ahead, Maria.
No, do you have anything to add to that question?
Nope. I was going to move on to the next one, but you can go for it.
Okay, thank you. So the next question, what is the deal with AWS ACLs not being stateful? DevOps keeps pushing back on using them in favor of security groups.
So this is not really a Kubernetes question, but I'm happy to talk about it a little bit. So the deal with them not being stateful is that AWS ACLs are applied at a somewhat different layer than security groups are. So if you think about a data center environment where you have a firewall that is stateful in your network architecture, and then you also have perhaps ACLs on a router, depending on the router and the router operating system and so on and so forth, often those router ACLs are also not stateful, similar to those in AWS. So the advantage of AWS ACLs are that it's a different layer in your networking architecture where you can apply a control to egress or ingress. But they're not meant to be used as a traditional firewall would. In fact, that's the role of the security groups that you're referring to, that it sounds like your DevOps team is pushing to use. So security groups are applied to network interfaces that are attached to your EC2 instances and other things like RDS, managed databases, and so on and so forth in AWS. And your ACLs are applied, not exactly, but I'm going to say for brevity at the subnet boundary or at the network boundary for your VPC. So think of the ACLs as a additional sort of perimeter choke point to help augment your security. But when you're wanting to have a firewall-like function, security groups really are the way to go.
Okay. Next question. How can you prevent an application being deployed to Kubernetes if it violates best practices like running as root?
Yeah, so that's going to use that admission controller that we referred to earlier in our content. And the way you go about accomplishing this is you have a policy, or in the case of Fairwinds Insights, we have a lot of policies that are built in that will leverage that admission controller and look at the pod specification of your Kubernetes deployment and see that you either aren't specifying a non-root user ID, or that you are you're leaving that user ID unspecified. And so if there's a possibility that a particular container image might be running as root, it's going to deny that deployment from being able to be submitted to the Kubernetes API. And so it'll keep that container from running with that configuration.
Okay, next question. How do we ship logs from containers to our central logging infrastructure if the containers might run for a shorter amount of time?
Yeah. So the way logs work in Kubernetes pods and in your containers is that anything that is output to standard output from your pod. So think of that like content that's printed to your terminal or to your screen. Any content like that is going to be collected and stored for a bit by Kubernetes as a quote unquote log. And that's actually made available by the kubelet, which is an agent that runs on the node of Kubernetes clusters. And you can have log agents. So for example, we use Datadog with our customers here at Fairwinds. And so you can have an agent that is also running in your cluster, still running as a Kubernetes deployment. And it's able to pick up those logs as they're stored, even with pods and containers being very ephemeral. It's able to pick those up from disk as put there by Kubernetes and ship them on a regular basis into whatever your central logging system is. So the thing that does change with respect to this is that you might be used to writing logs explicitly to a file in your application. And while it could be possible to pick those up using what's called a sidecar container in your Kubernetes deployment, the preferred practice for this is to switch your application design from writing logs to files to writing that log content to standard output so that it can be picked up how I just described as Kubernetes pod logs, and then from there shipped onto your logging system.
Okay, next question. How can I limit which container images can be deployed to Kubernetes so only trusted images are used?
Yeah, good question. So this also ties back to our policy discussion. So having policies with something like OPA that Kendall mentioned, that's also bundled in our product, Fairwinds Insights. But OPA is a general policy product. So when I speak about policy, you can accomplish this in Fairwinds Insights. You can accomplish this with other tools as well. You can write a policy that will look at your Kubernetes pod specification that's part of your manifest when you're deploying an app to Kubernetes. And one of the fields that can be inspected there is the image field. And part of that field includes the container registry that stores container images that Kubernetes will pull those images from that registry and run those containers in your cluster. So if you want to have some degree of control over the source of the images that you're running, you could have a policy that inspects the image field of your Kubernetes pod specification to make sure that those image registries that you're using are only in an approved set. And that might include an internal image registry that lives in the cloud and is private or runs on premise, that you're running some third-party image product. So through using an OPA policy, you can definitely inspect that image field and enforce use of whatever image registries that you feel are trusted.
Okay, next question. How do I control east and west network traffic between containers?
Yeah, so this relates to, I believe it was point number 2 that we referred to earlier on the slides. And if you'd like more dialogue around that, perhaps you can also consult the recording for this if you missed that content earlier. But to be able to control that traffic from pod to pod in your Kubernetes cluster, you want to use a Kubernetes resource called network policy. You also want to make sure that you use a CNI, which stands for Container Networking Interface, that supports network policy. So a network policy resource in Kubernetes, in and of itself, doesn't actually function unless you have a CNI that's installed in your cluster that will fulfill network policy. So something like Calico or Cilium, as just 2 examples, are CNIs that will facilitate network policy. So you want to use network policy, and you'll be writing network policy resources, and they are somewhat like firewall rules, if you will, for your Kubernetes pods.
All right, that is all the time that we have for questions today. Please join me in thanking Ivan Fetch and Kendall Miller for their great presentation, as well as our sponsor, Fairwinds. If you do have any additional questions or comments, please don't hesitate to click the email us button on the console. Please also visit securitymagazine.com for the archive of this presentation, as well as information about upcoming events. We appreciate your time and hope that you have found this webinar to be a valuable experience.